Hello, everybody. For those of you who are new today, my name is Whitney Turner. I'm a faculty member at the Johnson County Community College's Math Department. In addition, I am able to serve as the co-chair of the Kansas Math Pathways Task Force. As many of you know, we've been working on these professional developments for the last month and a half or so, and we are going to be overall implementing math pathways, co-requisite support, and statewide course placement measures. Since there are so many of us here today and more joining, it looks like still, I'd like to remind everybody to mute your computers and place any questions you may have into the chat. We have a lot of great presentations today, so we want to make sure that we have time for all of those. However, if there is time after our presentations, we'll of course leave some room for questions. Otherwise, we will answer those questions and get back to you after the presentation, which are going to be posted on the website where the last two presentation information has been. Due to time constraints, as we are going through these presentations, please make sure that you are, hold on. Oh my gosh, I'm so sorry. I had a bit of a coughing attack just then. I'm so sorry about that. As I was saying, due to time constraints, just make sure that you're using that chat function. Okay, we are joined by Dr. Udell from Kansas City, Kansas Public Schools, who will be discussing some frustration, discomfort, and growth mindset in the classroom. She is going to be setting us up for a wonderful discussion of things that we can practically and applicably do in our classrooms for these co-requisite support courses. Welcome, Dr. Udell.
Thank you. I'm so happy to be here.
Okay. Did you need me to share your presentation slides, or are you able to do that from your computer?
I can do it. Should we get started or do we need to wait?
Nope, I think we can get started if that's all right with you.
Okay, sounds good.
Okay, thank you.
All right. Where's my slideshow? Okay. Hi, everyone. Happy Friday. It's good to see everybody from all across the state. I was excited to be asked to come here. I studied growth mindset and frustration tolerance in mathematics when I was going to K-State for my doctorate, and had the opportunity to dig back into my research in a year or so, as my current position here in KCK keeps me very busy. So I'm excited to talk about this today. So my name is Dr. Ashley Udell. I live in the Kansas City area. My own kids, they attend the Shawnee Mission School District. I have experience as an elementary teacher in various districts around Kansas City and also Wichita, and soon wanted to move over to higher education. So I was an instructor at Emporia State University. And then after completing my PhD in math education, I decided to get back into the public school system. And so I currently work here in Kansas City, Kansas. If you're not familiar, we are a very large urban district. I have 29 elementary schools. So I developed the curriculum, just adopted a new resource, iReady, and am very busy supporting teachers and providing professional learning opportunities. So, like I said, I'm excited to talk about something a little different today. I continue to find these opportunities. Anything in education always excites me. A couple weeks ago, I was out in Lawrence facilitating a KISA professional learning and helping school districts from around the state look at their their KISA applications and talking about the differences in that. And so this is another great opportunity. I will have a little bit of time at the end if anybody has questions, and I also have a QR code at the end to share these slides because there's some things that are linked in here that you might want to refer back to. And also I'll leave my contact information in case anybody wants to reach out. Okay, so we're going to talk about a few things today. First, we're going to start with the implicit theory of intelligence in mathematics, which is kind of where I got started in my own research. And then as I dug deeper into that theory, I got into another researcher that had studied frustration discomfort, and I took a spin on that and kind of combined my two instruments for implicit theory and frustration discomfort to really focus in on mathematics. And so I'll tell you a little bit about that study that I did and some of the things I now are finding that are applicable to the actual classroom. And then we'll end with some strategies to help with productive struggle in mathematics. I work with classrooms from early childhood all the way up to seniors in high school in my district, and helping those teachers with some of these strategies to implement in their classroom with productive struggle. Okay, so as you know, we in Kansas, we have our own state standards that were adapted from the Common Core standards, and they really outline what students need to know for every grade level. And then we also have the 8 standards for mathematical practice to show teachers a little bit more how those Common Core standards should look like in practice in your classroom. So when early in my own teaching career, the Common Core state standards, you know, they were right whenever I got into my teaching career, was right whenever they were being introduced. And so there was a lot of huff and puff about it because they were different and they were weird and they were rigorous. And so I got to hear a lot of both sides, not just from educators and those in the education field, but from families too. And I have to say I appreciated the way that they focused so much on the process of mathematics and the different methods to problem solve, instead of solely focusing on solutions. And I see that a lot in the instruction that I see in classrooms today, how the shift is just different. You know, when I was growing up, much like you all, it was very traditional, maybe some I say kill and drill, like it's just it was a different way to teach, I think. So I could see how a lot of teachers were doubting it, but I really tried to make sense of it and to understand. I went to a lot of professional development myself to understand like the why. Like, why did we find ourselves here? Why did we think we needed to reinvent math standards? And why did we feel it was necessary to then align math standards with mathematical practices? And so then when the National Council of Teachers of Mathematics published the 8 effective mathematics teaching practices, that was very eye-opening for classroom teachers because it finally gave us a little bit of a direction as to how to teach this way. We had been trying to figure it out, and these effective mathematics teaching practices really allowed for additional research and publications to help teachers with the implementation of the standards and the practices. So as I was in my teaching career, I really loved the word persevere, and I loved that phrase productive struggle. And when it came to mathematics, I could see how these were skills that our students really needed, but like, how do I teach that? How do I teach a student to persevere? How do I understand the right environment for a productive struggle, and to support my students in that? So as I as I was starting to figure out what I wanted to research for my PhD, I kept finding myself back in this topic, I guess. So when I was at ESU, I love to start my semester talking about, growth mindset and why, you're here because you're going to be an educator and you're going to need to teach math. Granted, I was teaching elementary pre-service teachers, which are required to teach all content areas. But oftentimes they love teaching everything except math. Now, you all love math, so your mindset is much different than the students and the people that I've worked with in my entire career. But we talk a lot about growth mindset, and I give them the example, you know how to drive a car today, but think about the time that you had to learn how to drive that car. You didn't learn how to drive a car just by watching somebody and then all of a sudden, you were a master at it, and you didn't just read your driver's ed handbook and then you were a master at it. Like, you really just had to get behind the wheel and you had to take a chance and you had to just try. So that was a good analogy for my pre-service students to realize, math is one of those things where we just have to get in and try. We won't get better unless we try and keep trying over and over again. And even when you make a mistake, right? If you if you hit a curb, or you accidentally get in a little fender bender, you're not just never going to drive again. But we have to persevere, and so this analogy was helpful for my students to understand this is a skill where you keep trying, and every time you make a mistake, that is when you're learning. And so, but when you're in the learning and you're making those mistakes, like, that's the productive struggle. You're struggling because you're not perfect at it. You're still figuring out mistakes, but you're struggling productively. You're getting better and better and better and better. So I like to include this because it was a funny analogy for my students. Okay, so we're going to next take a survey. If you could, with your phone or your device, scan this QR code. This is the Theories of Intelligence Scale Survey, and it's super short. It's only 8 statements, and it's your typical Likert scale. But as you guys take this survey, I'm going to pull up some results for us to just take a peek at what our mindsets might be. Okay, so I'm going to stop sharing for a second because I have to switch my windows.
I'm not sure if this is relevant or not, but it says that this form can only be viewed by users from the owner's organization. Is there a permission that we maybe need for that?
Oh, the permission. Let me pull this up.
Sorry.
No, I apologize. Oops.
Do you by chance work for USD 259? Because that's what mine popped up, was the USD 259 login info.
Yes, let me see.
Would you be able to share the screen on your end and we could see the questions that way?
Let's do that. That's a good idea. I'm trying to see my settings, and that probably did happen, being on my district device. Okay. Here we go. Okay, so in this, the Implicit Theories of Intelligence Scale Survey, there are 4 statements that would tend to be a growth mindset and 4 statements that would tend to be a fixed mindset. And when I was studying, I studied the elementary and secondary education majors students at K-State. And so when I studied them, I did in my instrument, I mixed these up. But for this purpose, we'll just look at them in this order. So the first statement says you have a certain amount of intelligence and you can't really do much to change it. So hints towards a fixed mindset, and they would mark this on the Likert scale. And then your intelligence is something about you that you can't change very much. To be honest, you can't really change how intelligent you are. And you can learn new things, but you can't really change your basic intelligence. So you can see that these are indicating more of a fixed mindset where we don't think we can change our intelligence. And then, oh, you want me to fill it out? We'll go back over here. So then the next section, it has, are you going to make this? I apologize. I thought you guys would be able to do this. Here, I'll just mark this. There. Okay. So then we have 4 statements that would be the opposite. No matter who you are, you can significantly change your intelligence level. And you can always substantially change how intelligent you are. No matter how much intelligence you have, you can always change it quite a bit, and you can change even your basic intelligence level considerably. So on the Likert scale, you or students, they would indicate whether they agreed or they disagreed. And when we look at where our responses are, it's interesting to see, and this would be very interesting with students that aren't education majors, whereas in my study they were education majors, and I had a thought as to whether you're elementary or you're a secondary major, because if you're a secondary major and you may choose to be a math teacher, then you are choosing to take math courses, and your ability to solve math may change your mindset compared to somebody who might be a history major. But the responses would be either most people are disagreeing or most people are agreeing, or sometimes they were a little scattered. And it was interesting to see whether when we're answering a fixed mindset statement, and if we think it sounds super negative, so we are definitely going to disagree with it, or if it's a growth mindset statement, we're definitely going to agree to it because I definitely have a growth mindset. Or when we have some of those statements where our answers, they're a little bit all over the place. Like we're like, well, I think I know what I'm supposed to respond with, but honestly, like this one, on the fixed mindset, you can change even your basic intelligence level considerably. When they say you can't change your basic intelligence level, that's a question I notice sometimes. People are like, I don't know. Maybe you can't change your basic intelligence level. So these questions, they can tend to be eye-opening on what we really think our mindset's at. And then as educators, where is our mindset compared to how we teach, our teaching philosophy, our teaching structure, our classroom management in general, and how we're portraying that to our students? And in the elementary world, we would discuss a lot when it comes to various content areas. Where is your fixed and growth mindset? Because it seems to be that, we're on a spectrum. In some situations, I might have a fixed mindset. In other situations, I might have a growth mindset. For example, I'm living in this math world all day, but so I could have a growth mindset in that. And however, when it comes to cooking, I definitely have a fixed mindset. Like, I can't do this. I'll never be able to do this. Okay, so let's get back to our slides. So again, whoops, we went too fast. So items 1 through 4, they are more of a fixed mindset, and items 5 through 8, they were more of a growth mindset. And so sometimes the responses would be more sporadic if it was a statement where we were like, well, I don't know, I could see both sides. Or sometimes very dominant, especially, you know, if it's a negative statement, we know that that's going to be a fixed mindset. So it was interesting to see those responses. It would have been great to see your responses today to see where we were as mathematicians, where you all would be on that spectrum. Okay, we're going to watch a short video. Carol Dweck, she is the researcher behind this this theory of intelligence. And she talks about an entity mindset, which is our fixed mindset, and our incremental mindset, which is our growth mindset. So thinking about our mindsets able to be malleable, and as educators, we can mold them and transform them, or are they fixed? This is what it is, no matter what. So let me pull this up.
Today, I want to tell you about the power of yet. I learned of a high school in Chicago where students had to pass 84 units to graduate. And if they didn't pass, they got the grade not yet. I thought, isn't that wonderful? Because if you fail, you're nowhere. But if you get the grade not yet, you're on a learning curve. Not yet gave them a path into the future. And not yet also helped me understand a critical experience early in my career. To figure out how kids coped with challenge, I gave 10-year-olds some problems that were a little too difficult for them. Some of them reacted in a shockingly positive way. They said things like, I love a challenge, or I was hoping this would be informative. They understood that their abilities could grow through their hard work. They had what I call a growth mindset. But other children, for them, it was tragic, catastrophic. From their more fixed mindset perspective, their core intelligence had been tested and devastated. Instead of the power of yet, they were gripped by the tyranny of now. So what did they do next? In one study, after a failure on a test, they said they'd cheat next time instead of study more. In another study, they found someone who did worse than they did so they could feel better. And in many studies, we found they run from difficulty. Let's look at how that looks in the brain. Mosher and his colleagues measured from the brain as kids encountered errors. Processing the error shows up in red. If you look at the fixed mindset brain on the left, nothing is happening. But if you look at the growth mindset brain on the right, it's on fire with yet. They're processing the error deeply, learning from it, and correcting it. So, how are we raising our kids? Are we raising them for now or for yet? Are they focused on the next A or test score instead of dreaming big, instead of thinking about what they want to be and how they want to contribute to society? And if they are too focused on A's and test scores, are they going to carry this with them into the future? Maybe because many employers are coming to me and saying, we've already created a generation of young workers who can't get through the day without an award. So, what can we do? How can we build that bridge to yet? First, we can praise wisely. Our research shows that when we praise kids for the process they engage in, their hard work, their strategies, their focus, their perseverance, they learn that challenge seeking, they learn that resilience. Praising talent, praising intelligence makes them vulnerable. There are other ways of rewarding yet. We teamed up with game scientists at the University of Washington to create a math game, Brain Points. The typical math game rewards right answers right now, but not brain points. We rewarded process and the learning curve, so effort, strategy, and progress. The Brain Points game created more sustained learning and greater perseverance than the standard game. And just the words yet and not yet after a student has a setback, we're finding creates greater confidence and greater persistence. We also can change students' mindsets directly. In one study, we taught students that every time they pushed out of their comfort zone to learn something really, really hard and they stuck to it, the neurons in their brain could form new, stronger connections, and over time, they could become smarter. Those who learned this lesson showed a sharp increase in their grades. Those who did not showed a decrease. We have done this with thousands of students now across the country with similar results, especially for struggling students. So let's talk about equality. In our country, there are groups of kids who chronically show poor performance, and many people think that's inevitable. But when educators create growth mindset environments steeped in yet, equality can happen. Let me just give you a few small examples. One teacher took her Harlem kindergarten class, many of whom could not hold a pencil for the first month, through daily tantrums. She took them to the 95th percentile on the National Achievement Test. That same teacher took a 4th grade class in the South Bronx, way behind. She took them to the top of New York State on the state math test. That teacher is a Stanford grad, and she's here today. And another Stanford grad, a PhD student, Stephanie Freiberg, now a professor, went back to her Native American reservation in the state of Washington. She transformed the elementary school in terms of a growth mindset. That school had always been at the bottom of the district, at the bottom of the state. Within a year to a year and a half, the kindergartners and first graders were at the top of the district in reading and reading readiness. That district contained affluent sections of Seattle, so the reservation kids outdid the Microsoft kids. And they did it because learning a growth mindset transformed the meaning of effort and difficulty. It used to mean they were dumb, and now it means they had a chance to get smarter. Difficulty just meant not yet. Last year, I got a letter from a 13-year-old boy. He said, "Dear Professor Dweck, I read your book already." I like the fact that it was based on sound scientific research. That's why I decided to test out your growth mindset principles in 3 areas of my life. As a result, I'm earning higher grades, I have a better relationship with my parents. I have a better relationship with the other kids at school. I realize I've wasted most of my life. Let's not waste any more lives, because the more we know that basic human abilities can be grown, the more it becomes a basic human right for kids, all adults, to live in environments that create that growth, to live in environments filled, overflowing with yet. Thank you.
I apologize. I struggle with jumping from screen to screen.
Stanford University.
Hi.
Oh my goodness.
We are born
Stop it.
to learn, to develop our skills.
Okay, that's enough Carol Dweck. So let's see, where's my Zoom? So she was the first researcher that I started to study when it came to growth mindset. And as I studied her more, I specifically leaned in towards what does this mean in mathematics? I like how she talks about how we can tend to have a fixed mindset in an area where we tend to be really strong. So she says there's a mindset where people are enmeshed in their own idea of talents and specialness, and when things go wrong, they lose focus in their abilities. And sometimes I could see this with students that, you know, they are used to achieving their goals pretty easily. They're used to, you know, the strong students and the go-getters. But when they did have an obstacle, when it wasn't easy to succeed, they would shut down. And so all of a sudden I could see they actually had a very fixed mindset, even though they might have been a star student in math or whatever. But as soon as they were faced with an obstacle, they didn't have that perseverance, and they weren't used to a productive struggle in order to actually have a growth mindset in that area. And when we talk about growth mindset, we talk about mistakes a lot, and I'll keep referencing this later, especially as we get into Jo Boaler. But having an environment where we're celebrating mistakes and where we're using that as an example to learn is really the type of environment that we need to have for students to have a growth mindset. And let's look at. Let's start to look at Jo Boaler. So she states here, and Jo Boaler is a professor at Stanford now. I had the opportunity to go to a professional learning with her last year out at Stanford to learn more about this. But she says when students are asked to think intuitively, they stop thinking narrowly about a single method and use their sense-making and reasoning skills to consider the appropriateness of different methods. This right here reminds me of they're not new anymore, but our Common Core state standards that really took the rigorousness of our math and made it so that it was about the process and the reasoning and choosing a specific method based on how appropriate it is for that situation, which if you think is so much more applicable to the real world. We want students to learn math in the classroom in order to transfer that knowledge to the real world and be able to do math in the real world and in their career or wherever. But they're not always going to be able to do a standard algorithm with a piece of paper and pencil out in the real world. We want them to have many tools in their toolbox and be able to have that ability to choose a specific method or strategy to problem solve depending on how appropriate it is for that situation. So these are, like I said, examples of students that might have a fixed mindset in the classroom that wouldn't be most obvious. So the first one talks about the most social student might actually have anxiety, and it's being disguised as being so social. So they're very social, and they're good at the discourse and the engagement, but their mathematics is actually driving an anxiety, giving them a fixed mindset. The second example is about that straight A student, the strongest student in your classroom, maybe in reading and writing, but in math, again, it's something that they have been maybe told by a parent or a previous teacher, that math was hard, or goodness, how many times I've sat in a parent-teacher conference and the parents say, I stink at math, so I'm sure my kid stinks at math. And I'm like, well, it's not hereditary. But they're doing great, they might not know something yet, but they're doing great. So again, that power of yet. Or at ESU, when I was teaching pre-service teachers, and to be honest, even now as I attend PLCs and lead professional development with our classroom teachers in this district, I hear a lot about how, these traumatic experiences from when they were in grade school or high school or possibly higher education, where they had a teacher in math that just terrified them, or their mistakes were pointed out, or maybe they couldn't memorize multiplication facts and the time test just gave them even more anxiety. Oh, gotta love time tests. And then the last bullet says the fastest student in the classroom when asked to recite mathematics facts, who was unable to infer and problem solve when asked. And in the elementary world, we see a lot of that. Some students are able to sit there and memorize facts, but then whenever we are trying to transfer those skills to the real world and problem solving, they're unable to make those inferences, to pull out strategies and methods that they might be able to use, or could I do this, or could I do that? They just want to look at the two numbers in the word problem and just start adding, choose an operation and do it with those numbers, as I see a lot in our formative assessments. So Jo Boaler, she talks about how whether a student is headed towards the correct answer or not, teachers should be applauding the process and the effort, and so less focus on the actual solution. And I know when I go and model in classrooms for teachers, I really try to model that part. Like I said, we just adopted a new resource here in iReady, and every lesson starts with a try it, and it's to get the students to be immersed in a productive struggle, and to teach them to persevere through trying this way and trying that way. And it's not about the right answer. In fact, a lot of times when I'm modeling, I'll just put the right answer on the board. Let's just get that out of the way. Yep, this is the answer. Okay, now that we have that out of the way, let's talk about how we got that, why we got that. Why is this way better than this way? Why is this way quicker than that way, or more efficient? Or which strategies or methods would you need more visual representations or concrete manipulatives? And so it's all about exploring the process and the how instead of just that right answer. And then the discourse in the classroom around this processing should really, and I'll talk more about this at the end, should really be promoted by the teacher, the digging a little deeper, and the prompting and the encouraging and the questioning, to get the students used to being okay if I'm not quite sure if my method works or not. It's more about exploring the possibility if it will work, and then comparing my strategy to the other student strategy, my peer strategy. And so the ability for teachers to facilitate this type of discourse in the classroom, I know personally is another huge shift in our district. Gone are the days where I walk into a classroom and I'm wanting to see a teacher just standing or sometimes sitting at the front of the room and just sitting there modeling how to solve a problem with the standard algorithm over and over and over again, and then go to your desk and here's 20 more problems to do over and over and over again. It's not like that anymore. It's really about doing more of a discussion and less of a just practice independently. There's times for that, obviously, because we need to be able to check for understanding and assess at some point, but we have to make sure we're doing the work to get there first. And to get our students ready to do something independently it requires a lot more than us just modeling under a dot cam. Growth mindset is related to frustration tolerance, and that it should encourage students to interpret frustration as less ego-threatening. By enduring frustration and sticking to challenging tasks, students can make breakthroughs in their understanding of difficult academic material. So I want to shift a little bit over to frustration discomfort. So frustration discomfort, it was an area of study that I found from Dr. Neil Harrington, and he was a researcher and professor of psychology, and he based this scale on the literature and theory of rational emotive behavior therapy. So it really started off as more of his work as a professor of psychology, and then his later publications started pointing more in the direction of how is this aligned to our instructional practices in the classroom, and what are we seeing from students? So when I use this tool with my growth and fixed mindset tool, I was looking for those relationships between a fixed or growth mindset compared to a student's ability to tolerate frustration. And in the frustration discomfort scale, there are 4 factors, as you can see here. And just as I expected, if you have a growth mindset, then you're able to tolerate frustration, right? That's what we would expect. It supports the definition of a growth mindset. What was interesting is that I found, and again, this was a mix of, they were all education majors. They were undergrad, they were grad, and they were elementary, and they were secondary. So it was kind of a different pool. There were some variables there I could play with, but overall, it seemed that if they had a growth mindset, they were not able to tolerate an achievement frustration, which has continued to make me think a little deeper about this. And a type of person that has a growth mindset, what would be some of the ways that they would feel frustrated? And so, for example, if they weren't able to achieve their full potential, right? And I think about educators, we want to do it right, and we want to do it the right way. And so being prevented from achieving your full potential, you have a growth mindset, which in a growth mindset, you want to achieve your full potential. So I could see being frustrated if we're not able to do that. So it was an interesting look at the data when I have relationships that were very similar with discomfort intolerance, entitlement, emotional intolerance, and then I get to achievement frustration, and I was like, whoa, what's this? This is a little different. And my research also did indicate that the first factor, discomfort intolerance, it was a predictor of growth mindset. I believe it was like 3.9% or something. So yes, this is where I was talking about. So in theory, someone with a growth mindset would strive to persevere through obstacles to achieve their full potential, and therefore may be frustrated when they when they are prevented from doing so. Okay, so the goal in our classroom is to foster that mathematical growth mindset while we're decreasing our mathematical frustrations. So if we go back to our mathematical practices, one of them says make sense of problems and persevere in solving them, while our NCTM, the teaching practice, it states to support productive struggle and learning mathematics. So how are we combining these two, and what does it actually look like in the classroom? I need to see the bottom. There we go. So NCTM, they do define productive struggle as perseverance in completing difficult yet attainable goals that often have led to feelings of empowerment, efficacy, and hope. According to the Mind Research Institute, productive struggle is a state of engagement that enables students to work through increasingly challenging problems and new problems they have never seen before, thus requiring students to persevere. So what does this look like in our classroom? And the reason why I hone in on productive struggle is because it's combining, they're going to need to persevere in order to practice productive struggle, and they're going to need a growth mindset in order to practice productive struggle. But really, productive struggle is where we see our students grow. It's where they're going to go from, in my world, it's, you know, math intervention and hitting those prerequisite skills in order to be able to move on to the next grade levels. Where in higher education, it's, you know, completing the, well, now co-requisite courses along with your credit courses, your math courses. So in the classroom, the teacher poses a just right task and scaffolds, referencing visuals, manipulatives, and previous experiences. In my district, we have over 60 different languages spoken, about 73% multilingual. So number one is big for us. They are going to need concrete manipulatives. They're going to need visual representations before we get to abstract, before we get to a standard algorithm, in order to build that fluency and to be flexible with those with numbers and operations. Also, we talk a lot about how we're preparing students for algebra, but starting, you know, with kindergarten and what that number sense looks like up until we get into secondary education, which then would continue into higher education. And so taking the time to build that conceptual understanding at the beginning with a just right task, one that would have like a low floor and a high ceiling, like a number talk or something, where there's opportunities for students at various academic levels to engage in the discussion. And then building on the previous experiences, that comes into play a lot with language development. In my district is not just with mathematical terms, but a lot of the contexts that are around our real world applications, our word problems, is understanding the contents behind these math tasks in order to be able to understand what the problem is I need to solve and which method would be most efficient for this situation. So the teacher is facilitating classroom discourse with questioning and prompts to encourage students to participate in that discourse. And then sometimes asking students about their past math experiences. So what have you done mathematically that could relate to this situation? How are we building on that knowledge for this situation? And talking out loud about that thinking process. So the teacher modeling how to think through that process. And then the students are trying various strategies to solve. Again, very different from when I was taking my math methods courses, and you know, there's one way to solve and copy it down and memorize it and then spit it out later. So here we're wanting students to try and share their peers' strategies and different methods to solve using, they can write about it, they can talk about it, they can draw with it, they can use manipulatives. And then with this part, this is introducing discourse in this practice requires students to first think individually and have that quiet think time. It's this process of the teacher is presenting a mathematical problem to solve, and then allowing students to think about that context individually and then share what they think the context is. Sometimes just removing the numbers from the problem can allow students to figure out, what are we doing here? Who is it about? And where is it? And what's taking place? And what is the problem? And what do we need to solve before adding in those numbers? And then, so they think independently, and then they share with somebody. And then again, whenever they're trying strategies, they're trying first on their own quietly, and then sharing with partners, and then sharing in a classroom discourse, so that there's this progression of them being able to struggle productively kind of privately. And then whenever we're sharing in partners and then sharing in whole group, it allows for that mindset to kind of grow. So it's okay to make a mistake because everybody's sharing and everybody's just trying. And then we've already talked about, Dr. Dweck talked about praising students' effort instead of, the correct answer all the time, and especially their perseverance. So that those comments by a teacher will facilitate that classroom discourse and also model for students what that expectation is and what is so important about that your effort and your perseverance, you tried and you didn't give up. And hopefully you realize whenever one method wasn't going to be efficient, you didn't just give up. We didn't just get lost in the car and just sit in the car and not go anywhere. We had to turn around and we had to backtrack. We had to figure out a new route to go. Back to my driving analogy. And then, which goes into number 4, being able to persevere whenever their strategies aren't applicable or their solutions aren't accurate. So that's just another level of this type of productive struggle is I'm struggling to try, I'm struggling to get through it, I'm struggling to get it right. And when I get it wrong, I have to persevere to try again. So thinking about a way to practice productive struggle in your classroom is to come up with one problem, a problem that I mentioned before, low floor, high ceiling, where there could be multiple solutions, multiple methods to solve, and the strategies to solve could be represented in multiple ways, like concrete or pictorial or abstract. So for example, I was in a PD last week, I think, and we were working with algebra tiles. Gotta love algebra tiles. And so we were showing how to go from algebra tiles into more of like an area model, into our equations with secondary education, which is typically something that I see in my elementary classrooms, but we were extending that thinking to our secondary teachers to show them, like, this is how you build that conceptual understanding in algebra. And the students they're used to this progression. They've been doing this concrete, pictorial, abstract progression since they were little. Hopefully that's the idea. And so that is a way that they are very comfortable learning, whereas the teachers, we're the ones, especially in secondary, are not used to that, and we're not comfortable with that. And so we were trying to promote a little bit more of that. And then the authentic context, that's always just helpful for students to be engaged and relate to. So here are, and like I said, I'll have a QR code in a second for you to have a copy of these. But these are some of the resources I go to whenever I want to try a math task like that, where we can take the time to dig in and hit some of those deeper levels of knowledge. Joe Bowler has a great website, UCube, that has all kinds of mathematical mindset resources. And then the open middle problems, they're great for the low floor, high ceiling, and there's all kinds of different math topics that you can do with that. Earlier, I was talking about the way to promote that discourse in the classroom, and the 3 reads it's a strategy for language development that we use a lot, but it's a way to facilitate that discourse in a way where students are able to process individually and then with a partner, and then share art together as we continue to read this problem, this word problem, and dig a little deeper to understand what to do. Okay, well, there is the QR code if you are interested in these slides, and my email address if you have any questions. That is all I have to share today.
Thank you so much for that presentation. I feel like I learned a lot, and I'm definitely going to be looking into some of those resources for my classroom. Are there any questions? I think we have a little bit of time for questions. Are you comfortable answering some questions if there are some?
Sure.
All right, let's open up the floor to any questions for our there was a question in the chat. Could we put the QR code one more time? People were not quite quick enough to grab that.
Yes, let me do that.
Are there any other questions for Dr. Udell here? I did have a question while you're working on getting the QR code back up there. For the math frustrations, was there a point where students got to a level of so much frustration that they needed a break, or how did you handle that type of thing? Because that's going to be definitely something that we are all encountering in our classroom, where a student gets so frustrated with some of the algebra or mathematics involved that they just check out and then feel like there's not a way for them to come back into it. Is there any strategies that you know of to combat that type of thing? Have you encountered that?
So typically, and that's where the discourse helps, breaking up the instruction with opportunities for discourse, because it allows students to have an opportunity to kind of check themselves and check where everybody else is, kind of read the room. But typically, and that's the beauty of just trying to start with just one task, one rich task where we're still going to sit in it for a while, and to model how to, gosh, if I get stuck, what else could I do? I know it's different in my world, but in my world, I'm constantly reminding teachers, like, instead of telling the kid how to do it, how can you encourage them to persevere on their own and choose a different strategy on their own? And so in my world, it's very typical to see a lot of anchor charts up, a lot of math tools that are around the classroom, so that students are used to grabbing those whenever they do get stuck. But I think creating that culture of growth mindset in the beginning will help a lot of that. It will prevent a lot of students from just getting stuck or not knowing what really to do. But that discourse, it is a way for students to kind of check themselves and to realize, oh, I'm not the only one stuck. I'm not the only one that tried this operation and it didn't work.
Thank you very much. I appreciate that. I notice that sometimes my students struggle in that way, so I will be thinking about that. Are there any other questions for our presenter?
I will say it's hard to understand where's that sweet spot, right? I want to scaffold as much as I can so that the student is independently persevering and able to continue problem solving. But also, I don't want to let them just sit there stuck and shut down. We don't want students to shut down. And so looking into a lot of those question prompts and way to, to circulate the room and kind of read that temperature and make sure nobody is getting really frustrated. But the first day of my course, I would always give them the growth mindset test. It kind of helped me to know where they were standing on their spectrum of fixed or growth mindset, and also opening up that discussion of what are some of your math traumas that you might have, because typically almost everyone in my classroom, would talk about, gosh, in high school I had this one teacher, or, well, I've always been told everyone in my family stinks at math, so obviously I'm not good at math either. And so just getting that out of the way, just being like, yeah, you're right, some teachers suck. That's horrible. Yeah. But think about, how useful it is to use math out in the real world, and how you're going to need to use math in the real world. So that's why we're here, really, is to practice math here so that you can then transfer these skills out into the real world.
That makes a lot of sense. Yeah. Well, thank you so much for your presentation. Do you, if there are additional questions, are you willing to kind of hang out and answer those later, or do you need to leave right now?
No, I can hang out. Yeah.
Okay, just making sure. There might be some in the chat if people are thinking about this conversation. Oh, there is one right now. It says, I'm not familiar with the frustration discomfort scale. Can you talk a little about the different factors there?
Yes. So there were different factors when Dr. Neil Harrington created the discomfort scale. And I was going back to my slides. So discomfort and tolerance was just that icky feeling of like, I'm not comfortable. I can't tolerate being comfortable, or I can't tolerate being uncomfortable. Double negative. And then the second factor was entitlement. And so that was, you feel entitled. And so you get frustrated whenever you can't reach your full potential because of other people, right? And so those people that might, doesn't work well with others. So, that I feel like maybe they work better on their own, right? And so I will say in the frustration discomfort scale, there's 4 factors, and each factor has 7 items, and it uses a Likert scale, the 5-point Likert scale. And so for each of your factors, you would get a score to know where is my tolerance in this factor, and where is my tolerance in this factor. So they varied by that. And then the third one was emotional intolerance. So being able to just tolerate your emotions, which is different for everybody. And also each of these factors, it really depends on the context of the situation. When I was studying it, I used this instrument purposely for math. It was distributed in a math class. The directions kept targeting, your math experiences as you answer these questions. So I really transformed this instrument to be used in a math way. But again, he is a professor of psychology. So when he developed this, it wasn't necessarily just with math, which is why the 4 factors, maybe not all 4 factors would totally relate to mathematics. Whereas in that 4th factor, achievement frustration, I really saw that there were some relationships with a growth or fixed mindset based on achievement frustrations, which I could see that in a math class.
The person in the chat says, thank you for that information. Well, thank you so much for being here with us today and sharing all of your knowledge and information and resources. We really appreciate it. I think at this point we are going to change gears to our next presenter, just because we want to be mindful of our timing. So thank you so much. And I would like to welcome our next presenter, Jamie Goetz from Fort Hays State University's Mathematics Department. She's been working and developing a college algebra prerequisite course and is going to be sharing her approach. So thank you so much, Jamie, for coming and spending some time with us. Do you mind introducing yourself and giving a little bit of background?
Sure. My name is Jamie Goetz. I am an instructor here at Fort Hays, and this is my 3rd year teaching at Fort Hays, but my 11th year teaching overall. I taught 7 through 12 math in Ellsworth for 1 year. I taught 9 through 12 math at Hayes High for 7 years. So that's 8 years total. And then this is my 3rd year here. So this is my 11th year. I had to do that math. This is my 3rd year teaching the 105 course, which is College Algebra with Review, or the College Algebra with Prerequisite course. And I did inherit the course when I came to Fort Hays, but as we changed textbooks and we changed approaches, I changed the material to fit better with my teaching style and with the current students' learning styles, because as we all know that those change very, very quickly. So let me get my presentation here. All right, can everybody see that? I'm always like terrified when I present that nobody can actually see it. I'm talking to myself. Okay, so this is just kind of a run through of how I developed the course and my approach to the students to get them to learn. So the basics of 105, college algebra is 110. So we call college algebra with review 105. The major difference is it's a 5-hour course. So college algebra is either virtual or it is a 3-hour course. And our 105 course meets every day, which I love. We try to keep the class sizes very small. We have a cap right now of about 25, and we stick to that pretty well. We cover the exact same material that college algebra covers. It just moves at a slower pace. And we're going to talk about how to figure out that pace in a little bit. But that pace is to help the students. So we definitely do not have homework every day. I don't want to punish these students for devoting more of their time to succeed at math. So we do not give homework every day. We give homework at the conclusion of every section, every lesson that we do. And sometimes a lesson takes a couple of days. So I am somewhat traditional in my approach. I do a lot of guided practices. So I have an example here of what those guided practices look like, but I'm a little bit non-traditional in like what methods we approach with. So as you know, the true math teacher at heart, I want to see them solve it by hand, and we talk about how to do that. But we also want to relate how that solving applies to the sketch or the picture. So we also graph it, and then we talk about how to use graphing to solve different equations like inequalities or something of the sort. So this is kind of an example of just one thing that we do. You can see here what they would look like and what I would work through with them. And then I have a picture posted of my answer key of like what it would kind of look like by the end of it. One of the big things that I talk about in this co-requisite course is like, what does this mean in real world? What does this mean in normal people words? Because you find students get overwhelmed when you put them into a math classroom because we use a lot of phrases like at most or no more than or at least, and getting them into that math mindset can sometimes be overwhelming. So instead of saying, 2x squared minus 8x minus 24 is greater than or equal to 0, what does that mean in real words? Like, how can I say greater than or equal to in a way that isn't mathematical? So we talk about above, it means above, or it means more than, and then we talk about like, what does the 0 represent in this graph? So there's a lot of interpretation in this course, and I think that's really helpful to take the time to help them make those connections. Now, we do this for most of the lessons, but that doesn't mean every lesson is completely filled out. I'm finding that as students are coming to this post-secondary level that they are not informed on how to take notes anymore. They didn't learn how to take notes at the high school level, and I would love to teach them how to take really good notes, but I don't have the time to teach them math and problem solving and time management and how to take notes. So I feel that guided practices is just a really nice way of how to take one of those obstacles away. I'll give the guided practice, and what I'm writing on the board, you should be writing on the board too. But we also talk about how these are their notes. So if there is something additional they would like to put on it, like the translation of above the x-axis, then they should do that because this is how they're going to study. We also do a lot of Desmos activities. I'm a really big fan of Desmos. The self-pacing is really great. You'll see on some of my answer keys that I have highlighted what Desmos activity we are going to do. And you'll see that I'll have like, we're going to do slides 1 through 4. And then we do numbers 1 through 5 on our practice. And then we do slides 5 through 12 on the Desmos. That way I can kind of make them work together. This discovery or rediscovery, because most of these things they should have already learned at the secondary level, this rediscovery of things doesn't always have to come from me. And I ask my students for honest feedback a lot, and they do give it to me. One of their favorites is the graph transformation Desmos that I do for them. So instead of saying, well, the plus or minus k at the end of the equation moves it up or down, using this Desmos activity, they get to rediscover that. And it's a little more hands-on, it's a little more engaging, and it's a little more, oh, right, I remember that. And then we talk about it to make sure that they really did get that afterwards. Now the pacing is what a lot of people are really concerned about. The main thing that I do is I just try to keep on track with the 3-hour courses. I have taught College Algebra 110 in the past, so like I am familiar with what they need to get through. They also take the same final, just so we're on the same page. These students are not getting any different kind of materials. They are taking the exact same final as the 110 course, as the College Algebra. But we want to keep on track with that 3-hour course. So typically a 3-hour course gets through 3 lessons a week, give or take. So that's what I try to average. I don't stick to it, which was a very hard adjustment. I'm very type A, but I don't stick to it very, very closely. If my students need a little more time, I'm going to give them a little more time. But I try to keep on to that 2 to 3 lessons per week. So let's say on Monday, we started 6-1 and it was just multiplying polynomials and they did really well. Sometimes we can get through that in one day, just the same as College Algebra 110 can. But then the next lesson is factoring, and we need to do a little bit more prerequisite work, which I also teach intermediate algebra, which is like a prerequisite course for College Algebra. So I can take some of those other pieces of knowledge and lessons and bring them in and refresh their memory on some of these things, and it makes a really big difference. I also make my decisions based on my students' needs. As we are working through this lesson, and I think, okay, I think I'm going to need 2 days for factoring. And at the end of day 2, I see that they are still struggling. It's okay. I'm going to give them a 3rd day, right? Now, as the instructor, I have to make sure that I am respectful of the material, right? After like so many days, if we're not getting it, we're not getting it. We need to move on. But it's nice with those extra days built into the course and with the smaller class sizes, you get to know them. You have a relationship with them on a personal level. It's very, very small. And so we can see, okay, Jack in the back is really struggling and I need to make sure that I touch with him, or I can clearly see this entire class is quiet and that's not good. So we need to spend another day. Another thing I really emphasize with on this course is we have 2 review days for every single unit. It's just, we cover it over a longer time span. They see me every day. So a lot of material it seems like it was a long time ago. So giving those 2 review days to make sure that we're really understanding this is what my unit is covering, I think that's pretty important. The big thing that I want to touch on with this whole prerequisite course is it's not perfect. I am nowhere near done creating it. I am tweaking it every single semester. So last semester in my intermediate course, I discovered factoring with algebra tiles. And so I integrated it into intermediate course and I was like, okay, we're going to learn how to multiply polynomials with the algebra tiles and show how it relates to an area. And then we're going to learn how to break it apart into factors with the area, which turns into the grid method. And it was wildly successful. They did very, very well with it. So I tweaked it and I made it better for intermediate algebra this semester. And I like how it's going so well that I plan on integrating it into my prerequisite course for college algebra next semester. Now, that means I'm gonna have to add in probably 3 or 4 days, but I take avid notes on sticky notes as I teach. So this semester, if I taught a lesson and it went very quickly, went very well, I know that I can adjust how many days it needs for the future. So I am constantly adjusting this course. And I know that this course is not going to be the same this semester or next semester or the semester after, not only because of the type of students, but because of the way that they learn and the way that our society is shifting. You really do have to like shift your teaching methods to work for those students. When it comes to creating that course and working with that course, I have all of my lesson plans made. I have all of my answer keys made. And so if anybody is concerned or has questions or doesn't even know where to start, you're welcome to send me an email. I would love to help you. I would be more than willing to share materials with you. It has no impact on me, so don't be afraid to reach out.
Thank you so much for all of that information. I had just a quick question for you. So you said that you, as you're going through your course, you're taking notes on sticky notes. Has that been like more helpful versus like a overall review? How does that help with when you're going back and redoing it the next semester?
Honestly, I kind of do both. So like right here, I have a sticky note that's like revamp factoring. Here's my ideas. And then at the end of the unit, sometimes I have time to go ahead and make those changes how I want them to. And if I don't, then it's at the end of the semester. I go through and collectively say, okay, I needed a couple more days for factoring, but I can take a couple days away from systems of equations because they seem to understand that really well. Sometimes I do run out of time at the end of the semester and maybe we don't quite hit matrices or something. We all know that that happens. I just work really hard to make sure that isn't something that I'm heavily testing them on or isn't something that happens regularly. So it really is just an organization tactic that works for me. I guess it might not work for everybody.
Sure. No, I appreciate it. I feel like I'm gonna maybe start doing that. So that's great. Do we have any additional questions for Jamie? Okay. Do you mind putting your information in the chat just in case it was a little fast getting it off the slide?
Yes, I can do that.
Thank you so much. I really appreciate the discussion. I think we are going to head on to our next presentation just because we got 2 more to get through. Thank you very much. This one, actually, I'll be talking about some things. Let me go ahead and share my screen. Oops. Sorry, it might take a second here. All right. So I had a chance to talk to somebody who had done some research with the North Carolina Community College system. So this is going to be lessons learned from North Carolina. Let's see if I can. There we go. So Dr. Brianna Bentley from North Carolina State University, she's currently at William Peace College. She spoke with me for a while, as well as wrote her dissertation on exploring the experiences, mindset, math anxiety, and math self-efficacy of community college students and instructors in a co-requisite mathematics course. So basically, how are our students feeling in these co-requisite courses? She did surveys and interviews with 5 different community colleges in the North Carolina system. She had quite a few takeaways, and I would highly suggest reading her paper. It was very interesting and went into a lot of depth as to how the professors and the students felt about these co-requisite courses. I had quite a few takeaways myself, but there were some things that I wanted to highlight for us in Kansas. There was some pedagogical decisions that were made that had quite a bit of effect on the students' learning. So, four of the things that she focused on was the creation of a collaborative learning environment, use of real-world contexts, how instructors worked through problems, and the incorporation of study skill lessons. And these are also things that have been mentioned already today. So we're seeing these same types of things popping up over and over again in the research on how we approach these co-requisite courses. So the creation of a collaborative learning environment looks different, of course, for every classroom. It can be group work and individual work and discussion versus lecture. But what was found is that this collaborative learning environment was very effective for learning, but did not necessarily help students with their math mindset or anxiety or understanding how to approach the problems and getting what you wanted out of that course. However, the use of those real world context type problems really did help to reduce math anxiety and help students understand the material better because it allowed them to contextualize those types of mathematical relationships in their own life. The next one, how instructors worked through problems. So giving different strategies or doing it slower, working through individual steps, that type of structure was an effective learning tool, but also did not really help our students with their anxiety or mathematical mindset, but it helped them learn better. And then our last one, which we have talked a ton about in this, is the study skill lessons. This did help students with their mindset, and it helped them understand how to get more out of the class and how to get what they were looking for out of the course. There are several quotes that I wanted to get into from her work and different lessons that she discussed. So the first lesson is going to be the purpose and benefits of the co-requisite course. And I thought that this was really interesting. So she wrote that the students in this study were often worried when they signed up for a co-requisite course, specifically that they would fall behind and that they would not be able to keep up with the material. Because of course, 6 credits of math feels like a lot, right? These concerns quickly disappeared when taking co-requisite courses because they realized that the point of these courses was to help them be successful students and to give them time to develop their understanding of the material. So, if the advisors and instructors help students understand the benefits and purpose of the co-requisites, they could enter the course with a more positive attitude. Having a more positive attitude when beginning their co-requisite course could impact student success in the early weeks of the semester. So what this highlighted for me was that if we really help our students understand why they are taking the co-requisite course and how it is helping them towards their goals, then they will approach it differently. And there was definitely some students who talked about how, okay, by the end of the course, they understood why they had to take it and everything. But if we can help in those first couple of weeks, which are those really intervention weeks about how a student can do in a course sometimes, if we talk to them early on about the purposes of these co-requisite courses, then they might approach them with a with more of a positive outlook and a better growth mindset. The next lesson that came from her study was about communication. And this is communication between 2 different instructors. So when there are 2 instructors teaching the co-requisite and gateway course, frequent communication is imperative. This ensures that the 2 courses are aligned and that students are receiving just-in-time instruction. These 2 instructors should communicate at least once a week, and this communication should involve the content being covered, how it's being taught, and any changes to the original course pacing guide. So the reason that I wanted to highlight this one is that she talked about a story of that there was not great communication between 2 instructors with the same group of students. One taught the co-requisite and one taught the Gateway Math course. And there was not that just-in-time review that was seen in when you had a single instructor. And this was because they hadn't talked about, oh, sorry, we skipped over this other part and then came back to it later on. They just kind of went along in each of their courses. And so the students were not set up to be successful from the co-requisite in the Gateway course. And in addition, there was differences in solving methods. So the Gateway Math instructor had a very clear vision of how they were looking for something to be solved using like complete the square or some other type of structure. Whereas the co-requisite instructor taught almost a method that was a bit of a shortcut that didn't necessarily cover all instances of a type of problem and didn't really explain that. And so while it worked in their head for, oh, this is going to be a great method for this student and they're going to understand it, it didn't actually get to what the Gateway instructor was looking for in the course material. So as somebody teaching that Gateway Math course, understanding how you're looking for something to be solved and doing that communication piece with your co-requisite instructor is vital for the students' understanding, because they are going to be seeing a different perspective from a different teacher. So you want to make sure that if you're not identically aligned, at least there's a very good understanding and relationship between those two instructors. The next lesson would be just-in-time learning. And this goes off of that communication piece. And this is a little bit of what I just talked about. So it is imperative that colleges understand the importance of just-in-time learning and work to make sure that this characteristics of co-requisite courses is never threatened. One college used to pair one co-requisite instructor with multiple Gateway instructors. So essentially what happened is that there was somebody doing all of the co-requisite students and then lots of different Gateway instructors. So this ensures that just-in-time learning never happens for the co-requisite students, because all the different Gateway instructors were at a different point in their course. So they might have not been covering the same material on the same day. So with one co-requisite course, all these students were going off into different Gateway Math courses. That course design should not be considered by colleges, because then one of the most effective influences on students is being removed. In addition, colleges and departments can automatically list co-requisite instructors as observers in their paired Gateway instructors Blackboard or Canvas or whatever it is that our various schools use. This helps ensure that co-requisite instructor knows what the pace of the Gateway course is moving, so that they would be able to plan their course lessons more effectively. So the goal, again, is using that communication to facilitate just-in-time learning and to really keep that as a prize for the Gateway course, something that is vital to it. Another lesson learned in this study is the instructor disposition. And this one is hard for me because I'm not always a cheerleader. So I thought it was really interesting to see this as such an important part, that students responded well to instructors who obviously cared about them, praised them, and encouraged them. In addition, students liked instructors who considered mistakes to be part of the learning process and did not make them feel discouraged when they make a mistake. In addition, instructors should consider how to create safe learning environments for their students and should reflect on how to create this safe space in their classroom. One way this was accomplished by instructors in this study was through their use of positive reinforcement. Surveying students throughout the semester could help instructors reflect on if a safe learning environment has been created for their students. So we all try to have that safe learning environment, but we don't necessarily know if it's effective. So by surveying and talking to the students and trying to make sure that we are creating that environment is a great way. Additionally, she talked about the instructor's disposition and classroom environment, and what students cited when it came to those things that was very effective and allowed them to be comfortable in that classroom. And I thought it was valuable to hear these things. So positive and encouraging language, as well as disposition, kind of that cheerleading things, lots of you can do this type stuff. Encouraging mistakes as learning opportunities versus as like a punishment, right? If you do poorly on that exam, you can learn from it versus, okay, we just move on and don't come back to it. Caring about the students' learning, really checking in on students and making sure that they have the level of understanding that we're looking for. Positive approach to questions. So as a student asks a question, really taking the time with that student to make sure that they are getting that question answered. And then also encouraging questions in the classroom. And then, of course, one-on-one instruction. So utilizing office hours, utilizing group and individual work time in the classroom. This seemed very important to students and was cited multiple times as something that helped them a lot in their learning, was having that, that quick personal moment with their professor to help them on a particular type of problem. So those are some of the things that I found very useful from her study on the North Carolina Community College system. Are there any questions or anything? Sorry, I was looking at the chat. Are there any questions or anything that anybody would like some clarification on before we move on to our next presentation? Yes, there will be copies of the slides posted. They've all been sent to the person that will post them on the website. So they'll be posted as very soon on that after today. Are there any other questions? Okay, if not, please feel free to contact me, and I can always give you Brianna's information. She was wonderful to talk to and had a lot of interesting insights and worked with the co-requisites herself. So, all right, I'm going to turn it over to Dr. Connie Richardson to talk about just-in-time review and support.
Thank you, Whitney. Hi, everybody. If you weren't here at the previous meeting where I introduced myself briefly, I'm former math faculty. I've spent the past 12 years in supporting systems and states across the country in implementing math pathways, co-requisite supports, and multiple measure placement during my time at the Dana Center at UT Austin. I'm going to spend a few minutes discussing lessons learned, similar to what Whitney just did with North Carolina, but this is, systems across the country, and as they've innovated on the work and iterated on the work, and today especially in how departments plan and execute co-requisite content. I'll be joined in this session with Cowley College, Rachel Bates, and April Nittler-Beeson is going to speak for Cowley. And April, if you would go ahead and share the slides, please. Okay, and so lessons learned, planning co-requisite content. We're going to look at 4 broad categories. If you'll go ahead to the next slide, please. Let's see. Okay. So first thing is specifically related to content. I would recommend that you reconsider the Gateway course content pacing and sequencing. Some of this stuff, so this is going to be real high level, kind of pulling up some of the really big ideas that Jamie talked about, that Whitney talked about, that April will be talking about next. So when you think about, let's focus in on college algebra. If you're talking about college algebra, you've been teaching the course for years. You've had students at all different levels, and probably a lot of support content has crept into college algebra. But now, if you're going to have a support course or some support hours added onto the course, go back and look at what is that gateway course content, what is truly the college algebra content, and what is support. And that way, you know, what do you want your college level courses to look like? What do you want your college level with co-requisite to look like? The pacing and sequencing common across both, similar to what Jamie mentioned earlier with the 105 and the 110, layering in that support content. Secondly, promoting and honoring departmental collaboration. And we will dig into the departmental collaboration a little bit later. So you can go ahead and click on April to the third bullet, incorporating regular student feedback into departmental work and inspecting aggregate and disaggregated data throughout. We'll pick that back up after Cali College goes. So this, talking about departmental collaboration, we are in luck. I'm sorry to say that Dr. Brooke Eastis was supposed to be speaking on behalf of Cali College. She has had to step away, but luckily she collaborates so closely with April, and that April is able to step in for her today. And so Dr. Rachel Bates will do a brief introduction about Cali College and then turn it over to April.
I think that I'm speaking now, Connie, is that right?
Yes, I can hear you. Yeah, go ahead.
All right, maybe you can't see me. So I didn't have a slide for an introduction, but I just wanted to just tell folks that are joining us on this or who come back to the recording, a lot of the things that we're going to be discussing here in the next few slides and what April will be sharing with us is really things that have been in progress for some years prior to where the Kansas Board of Regents has asked us to move. And it really is in response to the work that the math department has done to recognize where students were maybe not having the most success. And so a lot of this has been as a reflection of that. I also wanted to just state too, again, you and I had the opportunity to work together collaboratively for many years. Most recently, when I was in Oklahoma, I spent 13 years. 8 of those years, I was a faculty member and a department chair of mathematics, where we were implementing pathways and multiple measures, co-requisite instruction. And then for 5 years, I was at the state system where we were doing that work across our 25 institutions, public and 2-year, or the 4-year and 2-year, I'm sorry, all public. But suffice it to say, I want to kind of focus on that number 13. This is not something that just goes away the minute that we, once you make it, it just goes away. It's a constant opportunity to continue to refine your processes. And it's something that some of the speakers had talked about before, that you're constantly going in and refining as you're making adjustments. And to the point you made on here at the very first slide about layering in the support, that is a model that I used when I was faculty. And I did a team approach or team taught with a colleague of mine, and it can work, and it can work very, very well. And so I'm going to pivot now and let April kind of share with the group the work that Cali has done with what we have is called the College Algebra with Review, and it is a 5 credit hour course. And I'm going to let April kind of talk through her slides next.
Okay, so I am April Nittler Beeson. I apologize. I'm not going to do Brooke justice here in this, but she did leave me her notes. I'm aware of the general idea behind her presentation, but I have not read through anything. And so I have taught at Cali for several years and have been here for a lot of the changes. And I think that back in fall 2013, with her slide here, this was kind of the beginning of when we started thinking, you know, things have got to change. We've got to look at things differently, and looking at different models for cohort, co-requisite, the jump starting, all of those different things. And we have tried just about everything here at Cali. And so then our current practice has been in place since about 2016. And now that doesn't, again, we are still tweaking. Like I've made tweaks to my class just this semester. I've started, you know, trying to implement some different things. So anyway, we'll kind of go over this. You guys bear with me. I didn't know I was going to be in charge of the presentation slides either. I apologize. So she has a slide here. I'm seeing it just like you guys are. So baseline data for academic years 2008, basically through 2011. This just shows how many exit points, and I know we talked about this at the last meeting too, how many opportunities when you have all of these developmental classes, how many opportunities there are for you to lose your students and for them to fall out. And so it seemed like we're taking these students who aren't very good at math and struggle with math, and we're trying to make them take more math, more and more and more. And so if you see this slide, and it's just, the numbers are just declining, and you barely have any that make it through the college algebra with a grade C or higher. I think it said 18, she has here 18% of the original 717 completed the sequence. And then she wanted me to talk about, sorry. So the past sequence, we've had elementary algebra, then intermediate algebra, then college algebra. We did have pre-algebra at one time, and we decided to eliminate that. Then we went with, we also had an elementary to intermediate, let me move my thing out of the way, to college algebra for online. And then we tried intermediate algebra with review to college algebra. That was definitely not successful. She has noted here that the intermediate with review had like a 45 to 50% DFW rate. So that was a horrible idea. But again, try and learn. And then what we currently have. So again, elementary algebra right now, we do offer that. So this is going to be a change for us because we know we won't. But right now, our elementary algebra students then go into college algebra with review. Set up similar to what we heard earlier. It's 5 credit hours. It is 4 days a week. It's we do the supplementation. Most of the teachers here, we do have academic freedom, so not everyone teaches it the same, but we do try to do as needed instruction, supplemental instruction. I know Brooke organizes her class a little bit differently than I do, and I organize mine a little bit different than some of the other instructors as far as sequence and things. But we try to do as needed instruction, and that seems to be working better. When we first started the college algebra with review, we just did we took the first 3 weeks of class and kind of did like a little boot camp thing, like we've talked in previous meetings. We tried that, and then jumping into the normal college algebra. And ours again takes they take the same final as the college algebra, so it's the same course competencies. Again, we have more time with those students. We are big on the growth mindset as well here. We try to work with those students, make the comfortable environment, try to definitely, we talk to our students, strongly at the beginning. It's okay to mess up. It's okay to make mistakes, because that's when you're going to start learning. That's when you're going to improve and actually use your brain. So, and then of course, online, we still are offering the elementary and the intermediate and the college algebra. But that's because some of our degrees still require the intermediate algebra as the course for those plans. And so, but we are going to offer college algebra with review online this spring. So we'll be piloting that to see how that's going to go. See if she has anything else. Just she and I did attend Joe Bowler's conference in 2017. And that's when we kind of started talking about the holistic and hands-on project-based learning, things like Bungee Barbie, if anybody's ever done any of the Joe Bowler stuff, just things like that. Something that Brooke has started is she wrote on here journals. just a way of students doing some reflective learning. I've incorporated like exam reflection sheets after their test to see kind of, you know, what did you do going into the test? How are you feeling? You know, those kinds of things. But she noted here that, sorry, I have to move this again. She asked what they struggled with most and how they overcome the struggle, where they found success in learning about the quadratics. This is something that she's been doing recently here. How they might continue to deepen their understanding. So things like that, that she has her students journal about. And so that's been a success in her class. She's the only one trying it at the moment. But I do know that she's enjoying that with her students. I don't know if the students are enjoying it, but I know that it's going to be good for them. I mentioned earlier, since we do have the academic freedom, you know, all classes are kind of taught a little bit different. They don't all look the same. But we do have some basic benchmarks. You know, we try to make sure that you're, you know, halfway through by the 8-week line. Although some, you know, and I've even tried doing like logarithms, like, you know, the first chapter of the year, trying to do that, and then just teach you know, as needed as we go through logs. Sometimes it's nice for all the students to start off on something that they're not sure about, instead of being in a class where some people are like, oh yeah, I can do this, and they're blurting out answers. And sometimes it puts everybody on the same playing field and kind of makes a different environment. So we've all tried, you know, just different things, just trying to meet the students where they are and see if we can get them to where they need to be. And then when I mentioned that they all take the same final exam as the college algebra class. And we're all of our offices are here in the same hallway. So we collaborate informally with each other to make sure that we are, you know, following KCOGs and everything. And so, and all of our instructors are attending the K-Board meetings. So we'll do our best for the new math pathways.
Thank you so much, April. I feel like we got a 2-for-1 here because we have Brooke's notes, but then we able to have April come in with color commentary on how she does her class a little bit different.
Yeah.
So thank you so much for being willing to jump in.
Sure.
Really appreciate it. If you could go on to the next slide, I want to give an example of some ways in which you can do a calendar and perhaps even, dare I say, common calendars. So I know that academic freedom is precious, but also that like-minded people can come together and collaborate and make things better for both sets of students. And so what I have for you is an example of a calendar plus a template by which you could build a calendar yourself. If you're not used to doing it this way, I'm sure many of you are, but this is for those people who may not be doing that. And I will drop these in the chat when I'm finished. I'm not great at dropping things in the chat at the same time as I'm talking. So this is an example from a college in Tennessee. And, you know, they were early implementers of co-requisites. And so we talked about college algebra, and you've had some great people you can reach out to today about college algebra. So I thought I would show a statistics example using the Triola book. Not that, you know, you could use any book, of course, but this example is Triola. And this mingles college-ready students and co-requisite students in the same class, and then the co-requisite students meet extra hours during the week. And they have a separate instructor because this college was having difficulty having enough instructors who were credentialed to do the college level statistics. And so they had to split it up. And so they decided that they would do a common course calendar. That way they could make sure that the students were getting the support when they needed it. They, in fact, also have a common course notebook across all of the sections as well. If there are any classes that are all 100% college-ready students, they get the same calendar. It just has the right-hand side, which is the college level content. The left-hand side shows the support content for the support instructor, so that support gets aligned. And it also includes embedded success strategies. So you'll see a little bit of that when you see this calendar, full size. And also something you'll notice in statistics, because there's limited algebraic skills needed for statistics, later in the semester, they actually have extra time for things like decoding problems. What does this problem say? And extra time to talk about results. And so that support content is really additional processing time once you get later in the semester and don't have as many prerequisite skills that you have to worry about. Next slide, please. So this is a template. The big middle column is where this is for the instructor planning, and the middle column is the crux. So that's the college level portion, would apply to all sections, whether they have the co-requisite or not. The right-hand column is where you can actually jot notes about teaching strategies, technology strategies that you don't want to forget about. And then the left-hand column is where you factor in those supports that are needed to build to the college content. After you have finished planning, then you can create the student version by stripping out that right-hand column, the student, you don't want the students knowing your teaching strategy secrets or what you're planning for technology. Strip out that right-hand column. If it's strictly a college level course, then you would also strip out the support. I would encourage you, even if you are one instructor teaching a course that is 3 or 5 or 6 hours, either it's co-requisite or not, but you're doing the whole thing and it's seamless, that you still plan in this way. And it helps you stay on track, right? If everybody's going to take this common final at the end, which both Jamie and April talked about, common finals for their courses. If everybody's going to take this common final and we're going to have common expectations across the department, then this is a way to stay on track. Now, there's going to be adjustments, of course, that you might have to spend a little more time somewhere, a little less time, but those should be the exceptions, right? We want to not be at the mercy of students who are not coming prepared because they know you'll slow down. We want to be encouraging students to stay caught up. And so by having this calendar where they can see where they're supposed to be at any given point in time, then you can make that happen. If we can go on to the next slide, please. Some further examples of department collaboration. Of course, I mentioned common assessments or even just portions of assessments, but also having common strategies across the department. If you see students have been either underplaced or overplaced, what to do with the student who is just whipping through all the support stuff. They don't need it. They start skipping it because they know they don't need it. Can you let them move? That's probably needs to be a departmental decision. If students are in the college level course without support, but they need support, can they move? Thinking about those sorts of things departmentally. Collaborating on your syllabi to create those safe spaces that Whitney talked about. Collaborating on professional learning. It might be that you're just holding in-house professional learning where you're sharing results and resources and teaching strategies. It might be that you're doing a book study or something along the lines of universal design for learning together. Or it might be that you are bringing in outside support or going outside for professional learning related to teaching, learning, and assessment. Next slide. So we talked about bullets 1 and 2, reconsidering the gateway content, pacing and sequencing, departmental collaboration. Just a couple of other high points I want to point out, and I think everybody mentioned this already, incorporating regular student input and feedback into departmental work. That if that becomes the departmental culture that we ask students for their input and feedback, what is helping you? What is not helping you about this class? You could even start that now, right? And it could help you in your planning for spring and next fall. And then finally, just to be sure and inspect aggregate and disaggregated data throughout, looking at Cowley's throughput data to see only 18% of the students coming out the other end of that sequence. And then if we disaggregate that data, there's probably subpopulations that are just all over the place around that 18%. It's classroom level data there, and throughput data, but also what's the retention in follow-on courses that depend on the math content? How are the STEM students doing in their STEM classes? Continuing to track students beyond the work will help you see if you need to go back and revisit your content. So that was really quick, and I appreciate your time. I'll drop those resources in the chat and my email. Happy to answer any questions or have a discussion with anybody at any time. Thank you.
Thank you so much, Connie. I really appreciate that. And those planning tools seem excellent. I am very excited to do that for the contemporary course at JCCC. That's going to be very helpful. I want to thank everybody for coming today. I know that we just have a couple of minutes left, and so there are some questions that were dropped in the chat. We'll make sure to answer those and post the answers on the website after this. Please continue to look at that FACT website for the Math Pathways work. We have another meeting on November 15th, again from 2 to 4 p.m. in about a month from now. Our speaker for that session is Dr. Kathleen Almay from Almay Education. She works as a consultant helping schools transform their courses and curriculum to work with pathways and co-requisites. I'm very excited about her presentation. She is actually going to be speaking at a MATIC earlier that week. And is going to be giving a presentation to help us again with some of those tools that Connie talked about and that some of our other colleagues talked about today, to help us in our co-requisite classrooms and to really help our mindset moving forward with these types of courses. So I really hope that you guys register for that one. Again, it's November 15th. The registration will be open, I believe, on Monday for that date. If there are topics that are important to you and you want to discuss or receive additional information on, please go ahead and email me. I will put my email in the chat right now as well. We really, again, want these sessions to be helpful for you. So if there are particular topics, there's a stats topic or a contemporary math topic or a college algebra topic that is continually coming up with your colleagues, please bring it to our attention so that we can try to help everybody across the state with that type of thing. And I'm trying to be mindful of time. Are there any last thoughts before I let you guys all go? Okay, thank you all for attending, and thank you so much to all of our speakers today. Dr. Jennifer Bonzracki, did you have anything that you wanted to say? Nope. All right. Okay, well, everybody, thank you so much for your time on this Friday.